encoder only modules, encoded encoder only modules. But
But
that's
that's not your note, right?
like my notes.
Ah, okay.
So how would this point of view? Well,
You have confused us more. Okay, 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 okay.
like
Thank you.
one more
One more
person.
person.
Okay. Uh,
Uh,
if
if Phil this time around.
like,
No, I want a female this time around.
so,
Uh,
yes.
yes. Mm.
Oh
Oh
yeah.
yeah.
Tell us
Tell
what.
us what you know about transformer.
Is that
Say
what?
what?
Alright.
Ore,
Yeah.
yeah.
Oh, yeah,
Oh
yeah.
yeah, yeah, yeah. Fire on.
From what?
From what you understand.
Yeah.
Yeah. Okay.
Try.
You tried. Well done.
All right.
All right.
So,
So
what's
from
the
what everybody has said, nothing.
You're
We're
wrong.
on. Okay.
So,
So
from
from what everybody said,
it
it
seems
seems
some of
some
us
of
are a
us are
bit
a bit
confused.
confused.
Why
Why
some
some
got
got
concepts,
concepts,
and some
and
of
some
us
of us
to
have
mix
to
it
mix
up.
it up.
And to
And to
solve
solve
that
that
problem,
problem,
it's
it's
not.
not.
I
I
might
might
just
just
do
do
like
like
a
a
10
10
minutes
minutes
recap
recap
on it.
on it.
Yeah.
Yeah.
But
But
again,
again,
please
please
don't stay
don't
with
stay with what
what I just
I just
explained in
explained in
class.
class.
You
You
have
have
to
to
do your
do
own
your own
research.
research.
Yeah.
Yeah.
You
You
don't
don't
have
have
to
to
be
be
a
I saw
I
you from there.
Okay.
Okay.
So
So
please,
please, you have to do your own research.
yeah.
Yeah, and all of that to get all of this thing right.
Yeah.
Yeah.
Okay.
Okay.
Yeah.
Yeah. Feed forward. Okay.
Yes.
Yes, feed forward.
Those
Those
are
are part of the components
of
of
transformer.
transformer.
Yes.
Yes.
So
So in the
image
image I showed to us,
there
there
is
is
a
a
place
place
for
for
just
just hold on a bit.
yeah.
Yeah.
So if
So
you
if
look
you look
at
at
it,
it, you see feed forward.
yeah,
Yeah.
this
This feed
for
forward is
multi-layer
multi-layered trans
perceptron.
perceptron.
That is
That is
where
where
the
the
transformation.
transformation happens.
That's
That's where the learning happens actually.
yes.
Yes.
Why
Why the
the
transformation happens
in
in
the
the attention head.
okay.
Okay.
So
So
it
it
transforms
transforms
first
first
before
before it
then
learns.
then
Then
it's
it's
normalized
normalized
before
before it
it
now
passes
passes it
to
to
the
the
decoder
decoder
for
for
it
it
to
to
mask
mask it
and
and
give you
give you
output.
output real time.
Okay.
Okay.
I was
Are we still in class?
okay.
Okay.
So
So
a
a
quick
quick
run
run through, and I
I
guess I've explained the reason why
I'm
I'm
always
always
taking
taking
time
time on
concept
concept,
because
because
if you don't
if you don't
understand the
understand the
concept,
concept,
there is no
there
way
is no
you
way
write
you
that
write that code.
and
And
it's
it's
like
like
I was
I was
taking
taking I was
teaching
teaching
someone
someone,
and
and
the
the
person
person
told me
told me
about
about
his
his
friends.
friends.
Or like
Or like
his
his
friends
friends can write code.
they've been
They've been
writing
writing
code
code
for a
for
very
a very long time,
and he
and he has not been fortunate to
learn
learn
programming.
programming.
So
So
I've
and
been
I've
taking
been taking in
programming
programming,
and
and
he
he
said
said
whenever
whenever
he
he
meets
meets
his
with his
friend,
friend,
he
he
sees
sees
their
their code
and he
and he asks them to
explains
explain it.
he
They
cannot
cannot
explain.
explain it.
So
So
he
he just started,
and he
and he
will
will
explain
explain
their
their codes to
them.
them.
Yeah.
Yeah.
And
And
this
this
era
era
of
of
AI
AI,
where
where
AI
AI
is
is
almost
almost
taking
taking
over
over everything,
the
the
code
code
you
you
might
might
not
not.
when you
When you
start
start
working you
working, you
might
might
not
not
write
write
code
code
from
from
approach
afresh
at
at
all.
all.
Even
Even
in our
in our
current
current place now,
public,
Publica,
yeah,
yeah,
most of
most of the projects,
or let
or
me
let me not say most,
some
some
of the
of the
projects
projects
we
we
work
work on
currently,
currently,
not
or
previously,
previously, I mean
currently,
currently, Those codes are brought to us, and you look at it. Does it fit to what I want to do? If it doesn't fit, you edit the code. You run the whole pipeline. If there's any mistake, you correct it, and all of that. So that is where the future is going. So the time you are supposed to spend, even though you still spend time, normally if you are supposed to work on a project, you can give it a week. You don't have to go out the code. You come back, submit the code, it must work. But now they give you the code, now and debug it, and come back in 2 days' time. It must work. So we have 3 days. We have gained 3 days that you can use to do extra. So if you don't understand concept, there is problem. Because when they give you that code and you don't know what the code is doing, there is problem. Yeah. So one reason why we spend more time in concepts than on a number. Okay, we've not even told you that you don't have to go out to decode yourself. The time is coming, obviously, where you just be giving code. You don't have to go it out. Whatever you think it means, that is good for you. If you can't figure it out, that's good for you. But not now. Anyways, we still have to hold you like a child till you're able to work. Yeah. So it's very important you understand concepts very well. Are we here? So especially for this architecture, we are going to fine tune. Yeah, you will fine tune, or you work with a team that will fine tune. They will give you code, and if you don't understand the flow, there is problem. Okay, so more reason for all of this. And if you don't get it now, the laziness to go back to it is uh, you may not likely go back to it. After now, this might be the last time some of us will see this architecture, because you won't go back to it. It's not that it's not there, oh, you won't go back to it. So it's better to know it the first time and just know it well and pass and focus on what is important next. Yeah? Are we in class? Okay. So quickly, sharply, I'll go through it again. For the last time, we have been doing this for the past how many days? Today's the fourth day, right? Fourth day. Today is Thursday. Aha. Okay. Yes. All right. So traditional model like RNN, what is RNN? Recurrent neural network. I believe the concept of recurrent neural network was clear. Yeah, how it works. Yeah, with long range dependency due to vanishing gradients and sequential processing. Transformers solve this problem through what? Self-attention mechanism, which allows all tokens to interact simultaneously. They are computationally efficient and scale well with data and model size. So this is the problem that transformer came to solve. And before you can put in the data, you have to tokenize. So that is where this is coming. Now, what is tokenization? So what I want to do today, and I'll be taking it back and forth. What is tokenization? Is the process of breaking down text into smaller units called what? Tokens. Now, if any of you have interacted with API before, has anyone bought OpenAI cloud? Is anyone that have subscribed for any of those AI stuffs? Nobody. It's okay. So you subscribed. Gemini, you subscribe, right? How many tokens did they give you? Limited. Okay. So, but how many of us have interacted with the public academy website and you have done practice? I say, well, yes. Who have disobeyed? Only two people. Did you see any place where they talk about token for the AI? Yeah, exactly. So, token is just the number of unit words that can be generated per time. So how do they arrive at that token? Each word was broken into their component parts to give rise to that token. So token can be words, can be subwords, or even characters, depending on the granularity of the NLP. Granularity from the word granules, yeah, still to break things down into finer particles, yeah, sugar cube. and you say you wanted grounded sugar. Now we dey call am grounded sugar. Sugar is granulated sugar. Yeah. So it is now in final granules. Do you get? So we can have a complex word, and a complex word can be broken down into granules. Okay, and those granules are the same thing as what tokens, depending on how fine you want the token to be. So the finest of all token is just a single character. C is a token. That's the finest, the smallest. Yeah. Why a word is also a token, but it is not as fine as, when I mean fine, I don't mean fine in types of size. Yeah. When we are talking about sand, you say fine sand, gravel, and all of this. Okay, so tokenization is fundamental step in text preprocessing, enabling machines to analyze and understand language. So the first step, yeah, towards working with transformer is tokenization. Now you can see it here. The time of our event, the time for our event, tokenization break down text into smaller pieces. Then you have the token, the time for our event. All right. So that is what token is about. So we'll leave this part of embedding. We'll come back to it later. Yeah. So I believe at this point, token is clear, right? All right. In how many different forms can we tokenize? Yeah. Words, subwords, characters. Yeah. So what inform our tokenization is depending on what the level of granularity required. So you have to know how granular should the word be. So when you hear words like dependency, can it be further broken down? Yeah. Words like accountability, can it be further broken down? Do we get? All right. So we move to back to transformer. So once you have broken your words into tokens, what happens next? The next thing is what? To embed that word. I believe we have been hearing embedding. For the next 4 weeks, we'll keep on hearing that word until it stays. Everybody here will build a vector database. Yeah, you take words, maybe a whole textbook, and you first chunk it, then you tokenize, then you build your vector database to persist. Yeah. All of these words I'm throwing around, I believe in 4 weeks' time, the world become parts and parcel of us, and it will become our new vocab. Yeah, but just be sure that you are noting the words down, because they're not just English. They will soon become language that you start speaking as a reason of your training, and it's okay to pay attention to them and to understand their meaning. And yeah, oh, is it from my end, engineer Abioye? Okay. All right. So one thing that helps me more when I'm learning something that is concept heavy, yeah, I'll first look for the common words that I use for that particular topic. I write everything down. I look at the literal meaning. I try to pay attention to the word as much as possible before going back to that textbook to read or to check anything. So when I'm reading, I am informed. I understand what I'm reading. And the words, before I know, the words will just be my tongue, and it will be easy for me to talk about. Yeah. So I think we will need all of that too, because the concept, there's a lot of new things you'll be hearing, so as to be able to keep up with the new terms. Are we still in class? All right. So embed is to turn a token into its numerical what? Equivalent. That is what embedding is. And why are we embedding? Because we want to be able to represent that word in what? Vector space. Are we together? Yes. So if we represent the word in a vector space, it will be easy for us to find the context relationship. Remember that is the problem that transformer is solving. Yeah, it helps us to what? It helps the machine to understand what context better without having to do too much looping. Okay, it doesn't even have to do looping. All it has to do is what? To look to its nearest neighbor and pick its nearest neighbor to itself, and they become one in meaning. So it pick the next till it's done with the whole thread of words. Yeah, and at that point, it's able to tell you the next word without just picking anything based on probability. Yeah, are we still in class? All right. So once it has embedded, the next thing is to give it what positional encoding. Why does it need positional encoding? In case if it leaves that particular position, it still remembers where it's coming from. Okay. For example, now, yeah, there's before that illustration. Uh, okay. Let's say for an African child, those people that were sold during slave trade, your skin color already says the part of the earth you are coming from. So even if they throw you anywhere in the world, once somebody sees you, this person is from Africa. So that is your own positional encoding. Do you get? All right. So you can fit amongst the whites, fit amongst the black, the Caucasian, and the rest of them. But you see, that's your picture. Still tells where you are from. So if there's everybody go back to your home, you will find your route to Africa. Even though some of us will go and stay in Gabon. No matter, Sha. So we've understood what positional encoding is, right? Then the next thing is what the multi-head attention. So what is multi-head attention doing? It is the ability of each token or each vector now able to pay attention to itself and to its what surrounding neighbor. That is what the multi-head attention is doing, and it doesn't do it in loop. Yeah, it doesn't do it in loop. So how I will explain it, there is this what I was telling you not, I said among the Fulanis, and I was trying to study them a little bit, and I was telling my friend that there is what they call the Fulani economy. An average Fulani man will not buy anything from anybody. If hunger let's just like cut his head, he won't buy anything from anybody. They always come back to his community to buy, and everything they ever need is within their community. And people are always coming to that their community to buy things, but they can never buy from you. Yeah, so it's like the fan economy. You see, if you put the back of the fan and use it to face you, one air will not touch your body until you face it to the front, right? So what it does is it just pay attention to itself. So it comes, it takes this, grabs coming. All of them became one. Pick this one, grabs it in. All of them became one. Until they start populating and populating. And you, God will help you. You just watch one person out of them. You have offended all of them. So that is just an illustration of self-attention. So they drag in, and they understand themselves. They keep dragging. They have money, like when I mean bastard money, but you won't know. Every other person come patronize them. All your money is coming into that community, but they are 5 naira. Do not leave that environment. Not 5 naira like this. It won't leave that environment. So that is just the explanation of self-attention. Yeah. So no matter how big their community is, they know everybody. Like everybody, as a stranger, they will know you. This one is not part of us. Like just like them, they know you. This one is not part of us. Yep. So that is just an explanation of self-attention. And once it has moved through the self-attention, remember it is still numbers, and some of these numbers can be outrageous because it's still in vector space, right? You can have something as much as minus 100, minus 80, minus 20, plus 200, plus 1, and all of that. But if the number is getting too much, that means it's attracting unnecessary attention. So what happens next is going to normalize all of those numbers so that it can be within the range of 0 and 1. So once it's within the range of 0 and 1, you can now move that into the neural network, the multi-layer perceptron. So it moves through the neural network and it learns the pattern. So in neural network, that is where the learning occurs. Yeah. Remember, the first part is to understand context. It has not really learned anything. All it is learning in the first part is context. Do we get the idea? Yeah. So when it's now moved into the neural network, it's now to understand all of the necessary pattern available. So from there, it moves up again and it normalizes. If it comes out of the neural network, it normalizes again, and that is the end of what the encoding. Are we good? Yeah. And I said the encoding and the decoding are the same thing, the same process, except for what the marked what attention. Now, most of the what's it called? Most of the architecture you see, they have varieties, right? And I believe we have seen the one I was using first has two blocks of this. And I said that is not really correct, right? And the one I used yesterday only had max multi-head attention. But if you check this, this is another note. You can see this is another note. This one also have what multi-head attention, feed forward. Yeah, but to always get the correct one, you can always get it the from the hold on. I'm looking for the okay. Okay, this is actually the correct one. So you can always get the correct one from this research paper. So let's go there. And I guess I've showed us this. Have we seen this before? Developers, have we seen this before?
Yes,
I mentioned it, right?
yeah.
Yeah, so it's okay if you go through it. Yeah, this is the correct this is the correct architecture, straight from the people who created it, who created the architecture. So this was what they created. So every other thing we see are just variants. So this is the correct thing. Is it clear enough? This thing is bluish. I don't know. Is it my eyes? Is it my eyes? It's blue, right? Oh yeah. Is it because I zoomed it? Alpha. Our this thing is blue. Is it? Can we see it? It's better, right? But it's a little bit blur. Okay. So this is the actual architecture, yeah, for decoding. So after mapped attention, it's moving it through multi-head attention again, then pass it through feed forward, normalize, then linearize it, pass it through softmax. And did I explain what softmax is? Softmax. Okay, softmax
is activation function.
all right, is activation function. And what is it doing? It is there to give it a probabilistic output. All right. If you remember the test I showed us yesterday that were in percentage, do you remember?
Yes,
Yesterday I showed us some pictures, black background, and you see the test. Yeah, they were in percentages. Yeah. So what is giving that output like that is because of the softmax. Are we in class? Yeah. So it's giving it a probabilistic output. So for all the possible what's available, so it ranks it in order. So and the one that has the highest The highest percentage is always the next word to be predicted. Do we get? Show you. So at this point, I believe nobody should have excuse not understanding what transformer is. So any question at this point? Question, question, question. Question, guys, before I continue. Am I permitted to move? So we saw all of this yesterday, right? We saw all of this yesterday. So there is, all right, let me go back to. So here is to help us get all of the intuition. So everything I've explained were overview, so that when you hear the big words, nobody will be confused again. Yeah. And in case you are interested in the code, see the code. We are only doing it once, and the truth is, nobody will ask you to come and build a transformer, right? It has been built, and no one is reinventing the wheel. But it's okay to know how it works. If you call yourself a developer or an engineer, because obviously you'll be asked in the interview or in any interview, oh, can you tell me how AI generates text? What is the foundation? You should be able to explain it. Yeah, but nobody will give you any test and tell you come and build a transformer. Never. But it's okay to know how it works. So the code is not a serious code. How many blocks do I have here? But this is purely NumPy. I didn't use PyTorch for this. Clearly NumPy. I just want to know how many blocks. Yeah, 14 blocks. So just 14 blocks of code. So it's nothing serious. The intuition is wait, all of this code I didn't write them from my head though. Yeah. But if you have the intuition, if you want to generate the code, in split seconds you can generate it. Even if it generates rubbish for you, you can look at it. I think this is not right. And you can correct it yourself. Yeah. All right. So if you are learning, we always want you to learn right so that you can apply rightly. So we'll go over this, not now, but let's finish with the intuition, because that is the most important part that you cannot trade off. Okay. So yeah, the intuition now. So please, you have to pay a lot of attention here. This is more practical. Yeah. More like I've dealt with the concept part. You understand what each word is and what they are doing. This is application part, intuition. So it's story like, so you need to pay attention so that you get it. So what is attention? So imagine you're at a busy market, yeah, and someone asks you, where did you buy that beautiful Ankara fabric? And your brain automatically focuses on the most relevant information to answer this question. So first we have high attention. So what is high attention? The specific store where you bought the fabric. We have medium attention, the section of the market. I mean the textile area where they sell clothes. Then you have low attention, unrelated details like the price of tomato you saw. Yeah, this selective focus is exactly what attention mechanisms do in a neural network. You see, this is more detailed, right? Do we get the gist? Are we sure? Okay. Can anybody summarize what is happening here? People that goes to market now. In your own words, trust me. I'm not asking you to give me what you say expressly. just from a point of understanding. Anybody who will go for us? Miss Rachel. Yeah. All right. Thank you. Yeah. Sir? Okay, sir. Yes, sir. Mr. Oluwole, we are with you, sir. All right, sir. Okay. Yes. That's a perfect illustration. So uh this is how the self-attention work. Yeah. So it segments things into level of attention. The high attention, medium attention, and what? Low attention. So it knows what to pay more attention to. So if you are having words like this is a man, so the attention should not be on is. Yeah? Where do you think the high attention will be? On man, because he's the object. Why medium attention should be what? On this, the subject. And low attention should be on what? The verb. Are we here? Awesome. We move. Yeah. So from human attention to machine attention, traditional neural network like the RNN, when processing sentence like Kemi bought beautiful Ankara fabric at Balogun Market, the model process each word sequentially and might lose track of important connection. So because it's sequential, yeah, you lose what is important. Now, this is how that works. Yoruba will say 20 children cannot be friends in 20 years. And that is true. Your friends when you were young, even now, if you guys meet, it's not those good times. You cannot feel vibe again like before. Yeah. So that vibe would have reduced. So that is what this place is saying. For RNN, over time, you lost the sense of context. More like, oh, they follow the playboy before. But now, you forget as guy will talk, but you don't share. It is at that time. You have lost the sense of context. Like you've forgotten whatever has happened in the past, and you just want to move on. But for attention, it doesn't move on. It keeps it up. Yeah. So we'll continue. Instead of processing words one by one, attention allows each word to look at and communicate with what every other word in the sentence simultaneously. You understand what I explained with Fulani economy, right? Okay. So we move. Self-attention mechanism. The problem with traditional RNN in Nigerian language, for an example, imagine you are trying to build a system to translate Hausa to English. Okay? Consider the sentence. I don't understand Hausa, please. Who understand Hausa? Read it out loud. Oh yeah, just read it out for us. Toiba. Oh yeah. Okay. The boy who came yesterday brought a beautiful book. All right. Are we here? Hello.
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 Are we
Are
still
we
in
still in
class?
class?
Okay.
Okay.
So
So
here
here
now,
now,
they say
they
in
say in
traditional
traditional
RNN,
RNN,
pay
please pay
attention, I
attention,
beg
I
you.
beg you.
In
In
traditional
traditional RNN,
process
processing
happens
happens
sequentially.
sequentially.
Step
Step
one,
one, it
process
process
iron.
yarn,
That
that
is
is
boy.
boy.
Step
Step
two,
two,
da,
da,
who
who
or
or
what.
what.
But the
But the
connection to
connection to
iron
yarn
starts
starts what?
fading.
Fading.
Yeah.
Yarrow.
Okay.
Okay.
Don't.
Don't blame me.
All
All
right.
right.
Step
Step
three,
three,
it's
it
process
process
yeah,
ya,
he.
he.
Four,
4,
so
zo.
five,
5,
GR.
gia.
Six,
6,
yeah.
ya.
Connection
Connection
to
to
original
original
Yaro
yarrow
is
is
now weak
now weak
at this
at this
point.
point.
How
Kao
brought
brought,
laugh
laugh, the book.
say
Say
by the
by the
time
time
we
we
reach
reach
Kao,
Kao,
which is
which is
brought,
brought,
the
the
RNN
RNN
has
has largely
forgotten
forgotten
about
about
Yaro,
yarrow,
making it
making it
difficult
difficult
to
to
understand
understand
the
that the
boy
boy,
what the
what the
boy
boy
is
is doing.
doing.
Uh,
Hold
hold
on.
on.
Making it
Making it
difficult
difficult
to
to
understand
understand
that
that
the
the
boy
boy
is the
is the one
one
bringing,
is the
is the
one
one
doing
doing the
bringing.
bringing.
Yeah.
Yeah.
So
So
this
this
is
is
the
the
weak
weak
point
point
of
of
RNA.
RNN.
So
So
attention
attention
solution.
solution.
Attention
Attention
mechanism
mechanism
allows
allows
the
the
model
model
to
to
directly
directly
connect
connect
any
any
word
word
to
to
any
any
other
other
word,
word,
regardless
regardless
of
of
what
what
the distance.
distance.
Right?
Right?
So this
So
is
this
the
is the
beauty
beauty
of
of
generative
generative
AI.
AI.
And
And
the
the
technology
technology
behind
behind
it
it
was
is what?
transformer.
Transformer.
So this
So
is
this is
just the
just the
core.
core.
All right.
All right.
So when
So when processing
cow
cow
brought,
brought,
attention
attention
can
can
directly
directly
look
look
back
back
at
at
Yaron.
Yaron,
Who is
who is
bringing
bringing
the
the
book?
book,
What
what
is
is
being
being
brought
brought
yesterday
yesterday
when
when
it
it
was
what
happened.
happened.
And
And
all of
all of
this
this
is a
is a
symbol
symbol
of
of intelligence.
yeah.
Yeah.
So that
So
is
that's
what
why we can say
that
that
stuff is
stuff is
intelligent.
intelligent.
But per
But per
se
se
is
is
all
all
programming.
programming. Anyways.
So
So the
what
core
is
concept,
attention
attention is
for you?
all you need.
Think of
Think of attention like a Nigerian market scene in Balogun market.
query.
Query.
So the
So the
three
three
parts
parts
of
of
attention
attention
is we
is
have
we
the
have the
query,
query,
we have
we
the
have the
key,
key,
and
and we have the
the value.
values.
Q,
Q,
K,
K,
V.
V.
Please
Please
take note
take
of
note of
that.
that.
Key,
Key,
query,
query,
value.
values.
So what
So
is
what
the
is the
query?
query?
A
A
customer
customer asking,
where can
where
I
can I find
account
Accra
fabric?
fabric?
That is
That is
what
what
we are
we
looking
are
for.
looking for.
Keys,
Keys,
the
the
shop
shop
signs
signs
and
and
display.
display,
Displaying
displaying
what
what
is
is
available, what
available,
we
what we
want
want
to
to
buy.
buy.
Then the
Then the values, the actual
products
product
on
on
in
each
each
in each
shop,
shop,
what
what
we
we
got
got
eventually.
eventually.
Show you.
Show you.
Okay.
Okay.
So this is
So this is
how it
how it
splits to
splits
get
to get
its
its
meaning.
meaning.
It splits
It
it
splits it
into
into query, the
question.
question,
Keys,
keys,
the
the
actual place,
actual place,
what
what
we are
we
looking
are looking
for,
for,
and
and the
the value,
value,
what
what
we are
we are
getting
getting
at the
at
end of
the end
the
of the
day.
day.
Are we
Are
good?
we good?
So
So
attention
attention
mechanism is
mechanism is
like
like
the
the
customer's
customer's
ability
ability
to
to
scan
scan
all
all
shops
shops
simultaneously
simultaneously
in
in
all.
all,
Let's not
let's
forget
not
that
forget
word.
that word,
Simultaneously
simultaneously,
and
and
focus
focus
on the
on the
most
most
relevant
relevant
one
one,
rather
rather
than
than
walking
walking
through
through
each
each
shop
shop
one
one
by
by
word.
word.
Okay?
Okay?
Yeah.
Yeah.
So that
So
is
that is
like you
like you
trying to
trying
buy
to buy
something from the
something from the
market
market
and you're
and you
seeing
are seeing
everything
everything
shaded on
shaded
the
on the
floor.
floor.
Just with
Just with
your
your
human
human
intuition,
intuition,
just look
just
at
look
the
at your
bank
bank
and you
and
go
you
to
go
the
to the
third
third
person
person
because you
because you
feel
feel okay,
I can
I
buy
can buy
from
from
that
that
person.
person.
So you
So you
just
just
scan
scan
and
and
you
you
went to
went to
where you
where
want
you
to
want to
get the
get the
stuff.
stuff.
Exactly.
Exactly.
So
So
that is
that
what
is what
it's
it is
saying
saying
about
about
attention.
attention.
All right.
All right.
So
So
why
why
attention
attention
works so
works so
well?
well?
One,
One,
direct
direct
access.
access.
No
No
information
information
lost
lost
through
through
sequential
sequential
processing
processing
compared to
compared to
RNN that
RNN
will
that
keep
will
on
keep on
looping
looping
and it
and it
forgot
forgot
what it
what it
started
started
with.
with.
But
But
for
for
this,
this,
no
no
information
information
lost
lost
because what?
because what?
It
It
drags
drags
everything what?
everything what
To
to
itself
itself
and
and
everything
everything
keeps
keeps
its
its
meaning.
meaning.
Yeah,
Yeah,
one
one
after
after
the
the other
other
without
and
losing
losing
its
its
meaning.
meaning. Okay.
Okay.
Two,
Two,
parallel
parallel
processing.
processing.
All words
All words
processed
processed
simultaneously.
simultaneously.
And I think
And I
that
think
is
that
the
explains
parallel
parallel
processing.
processing.
Engineers.
Engineers.
Yeah?
Yeah.
I
I
explained
explained
it
it here,
right.
right?
Using
Using the computer course
as
as
example.
example.
Yeah.
Yeah.
So it
So
can
it can
process
process
as
as
much
much
data
data as
as possible
possible
since the
since the
road
road
has been
has been
expanded
expanded
to
to 7 cores or to 8 cores or to 16 cores. So it can move freely this way, it can move freely this way without any hold up. So things are happening fast and quick without problem. Three, flexible focus. Model learns what to pay attention to. Okay, it knows the high attention, the medium attention, and what the low attention. Then number four, context preservation. Long range dependencies are what maintained. So even if it is 1 million words, it will generate it step by step. So the only reason why GPT, as at last year, it has a limited context window is because they defined it that it cannot generate more than this. Yeah, but I think this the new version can generate as much as possible. The only problem it now have with the context window is if you now copy the whole your the whole of your code and you put it inside, then you cannot process it. I should reduce it. Abi? Yeah. The reason why I'm telling you that is because of the context window. It has been reduced. Okay. So, but if they don't reduce the context window, it will do the work. Yeah. All right. We move. Is this part clear? And I also need you to pay attention to this part. Yeah. Let me speak like a Mr. Suma, a typical MCQ question. All right, I move. Geometric interpretation. All right. So what we just did was the intuition behind it. So this is the geometric intuition now. Okay, so let's get this part clear. So in vector space, attention measures similarity between vectors. And I believe you have been making mention of similarity search, dot product, cross product, one more, cosine similarity. You've heard me made mention of all of this, right? Yes. So this is this first sentence should at least drive that point home. In vector space, attention measures similarity between vectors. From the picture I showed us yesterday, does this make sense? Yeah? Okay. Similar vectors, that's word with similar meaning, have higher attention scores. In Yoruba, Omo and Omode, young person, would have high attention. In Igbo, Nna and what? Papa, okay, would attend to each word. So we attend to each other strongly because what they are what related. From the picture I showed yesterday, I think we're man, woman, right? Then niece, nephew, I think so. Yeah. So that is the idea behind the geometric interpretation. So it works with what distance in terms of similarity, closeness. Yeah, closeness in vector distance. And I told us with vector in a vector space, you can calculate distance, abi? Points and points, then you can connect the two together. So the ones with the closest line are highly related, and if they are in the same direction, they have more relationship compared to if they are what in opposite direction. Yeah, because this one is negative and this is positive in a dimensional space. You remember? Awesome. Okay. So this is the geometric interpretation of what self-attention is doing. So we move the mathematical foundation now. Step, please pay attention. Beg you. I'm not a mathematician, but I will try. I'll try my best. Oh? Okay. So the attention formula, we have attention brackets Q, K, P. Who can tell me the meaning of Q, K, P without looking at the question? Awesome. Query key and values. Then it is passed into what? The concept of activation function. Yeah, it is passed into the activation function as what? Q multiplied by K. Okay, over
divided by square root of d.
Multiplied by what?
Vector.
Value. Okay. Okay. So let's break it down. Let's break it down with Nigerian context example. So I try with all this thing he did. Okay. It's supposed to be not format itself. All right. Nigerian proverb translation. So we go. English. When the spider web unites, it can tie up a lion. Yoruba. Someone please read. Okay, thank you.
So,
So
step by
step by step.
hello,
Hello,
hello.
hello.
Okay,
Okay,
for the
for the
query,
query,
what's the
what
current
the current word is looking for.
so when
So when
processing
processing,
tie in
tie in
English,
English,
Q
Q
represents
represents
what can
what
be what
can be what
tied.
typed.
K,
K,
what each
what
word
each
can
word can
offer.
offer.
Lion
Lion
has
has
a
a
key
key
representing
representing
something that
something
can
that
be
can be
tied
tied
or
or
constrained.
constrained.
Spider web
Spider webs
has a
has
key.
a key.
Things
Things
that can
that
do
can do
tying.
tying.
Please follow
Please
closely.
follow closely. Oh.
For the
For the
value,
value,
the
the
actual
actual
content
content
now,
now is
value,
the value. Remember,
the
from the
market.
market example.
Yeah?
Yeah?
Okay.
Okay.
Lion
Lion
contains
contains
information
information
about
about
being
being
a
a
powerful
powerful
creature.
creature.
Spider web
Spider webs
contains
contain
information
information
about
about
being
being weak
individual
individually
or
but
strong
strong
together.
together.
So if
So if we
I'm
are
pushing this
pushing this
proverb
proverb
into the
into the
transformer,
transformer,
this is
this
how
is
it's
how
going
it's
to
going
break
to
it
break it
down
down
to give
to
you the
give you the
meaning.
meaning.
Do
Do we
get
get
the
the
gist.
gist?
It
It
comes.
confused?
All right.
All right.
Oh,
Oh
yeah,
yeah, let's look at it again.
all right.
All right.
So,
So
Nigerian
Nigerian proverb example.
let's
Let's pay attention, please.
uh,
Uh,
when the
when the
spider
spider webs
webs
unite,
they can
they can
tie
tie
up
up
the
a
lion.
lion.
The
The
interpretation.
interpretation.
Now
You have a question?
1 minute.
1 minute. What's time?
Left.
11:27. I'm not placing another meeting again. You guys are going for break. I don't want to go for break. You can continue.